Welcome back. Today we'll be continuing our lecture on the previous same subject, which is of CAE-CAM. Now in this, previously what we have covered is basically the coordinate systems and your LCD displays, how they will be working. And next we'll be continuing with our database structure for graphic mode. Now, what do you mean by database, to be precise, is a collection of data, right? A collection of data on a main server or any particular storage which stores the data for your model or part geometry in case of the CAE-CAM. In case of your computers, it will be simple binary coded digits. Now in this case, this data, whatever we have discussed, will be what it does basically have. If you are using the same data, you are having a data for your geometric model. Right? For geometric model, what will be that data has is basically your areas, volumes, inertias, as well as your vertices, vertices data, edge data, and solid as well as surface data, which collectively form or give you a few properties for your geometry model such as area, volumes, inertias, etc. Now in this, all this data is supposed to be saved with respect to your model under your database or a data storage device. It can be portable or fixed dependent on the type of workstation we will be using. Now that function, that database will act as temporary storage to manipulate the data which is to be displayed on the screen, such as whenever you are zooming or panning. What do you mean by zoom is to zoom in or zoom out, basically is to scale up or scale down your geometry, whereas for panning, to move or translate a model along a 2D plane, to be precise, either in this direction, either in this direction, right? Anyone. No. And whatever the database it is being generated, that is being stored and referred with respect to your database, the primary database, with the user, essentially for the purpose for editing functions like trimming, fillet as well as stretching. These all are your few operations that you will be doing for your geometry in order to get your final model out. And also you evaluate areas, volumes as well as inertias. You will be collecting the data from the database, as well as to provide any additional information for manufacturing specifications, right, in order to specify how well you will be having this. Next, under database, you first will identify with respect to your geometric model. Right, whenever a geometric model is being created, what are the types of data that are available or that are made available while creating a geometric model? First, these are categorized into two types. First is the organizational as well as technological data. Right? What do you mean by organization? There's organization is wherever you will be working or wherever you are employed. It can be freelancer or a complete full-time employee or part-time employee. Wherever you are employed, whatever the drawing or part design you are doing, not as your own, but as a employee, as a person who is working for other organization, that data related to that company, every data that is associated with respect to part as well as the company, you will be calling it as organizational data. In that, first will be your identification number. In an organization, there will be plenty of drawings available under that database. So, in order to identify a particular set of data, you will be having a particular identification number to be found. Next, drawing number. Drawing number suggests is whenever a 2D drawing has been made, a specified number for that particular sheet or a particular part will be allotted. The same part can be identified further on over a period of time by specifying an identification number as well as a drawing number. Next is your design origin. Design origin as well as status of changes states that whatever the design, particular geometric model and draft model which we generate is basically, is it originated from the same place or is it been modified or updated from any one of your previously drawn drawings that you are keeping as a separate file database which keeps a record. Now same thing, if you are putting any status of changes, let's say till now I will be putting a particular workpiece that a particular edge has to be changed, right? Edge has to be changed to form a small curve, right? Just a second. Right, let's say it's a cube. I want it to be modified to create a small curve or a small cylindrical bar at the end. Right, this is the change, the top as well as bottom is that I expect. Right, this changes is from my originally is one cube, but this will be updated in reference to my original data, which is my design origin, and the status will be updated accordingly as we do the modification to your original part or original drawing. Next will be your current status, which means if an object, particularly the what we example taken as a cube, what is the current status of the part, which states how well you can do, right? What is the current status for the drawing? If it's under modification or it's under editing or it's already been done in transformation is required, what is the current status to be modified, approved, or is waiting for any approvals from a standard authority? All these things will be coming under current status. Next will be your designer name. Designer name basically the person who designs a model. Can be a draft part as well as the 3D model. Whereas for date of design, as the name suggests, the date at which the design has been made and been approved for. And what is the scale? Scale can be global as well as local. Right? Under these two, what happens basically is global scale is same for the whole drawing sheet or the whole 3D model. Right? As we know, while drawing, you will be having a small title block which consists of scale. Right? That scale suggests that the scale is for whole sheet, and whenever you are considering for or whenever we are enlarging or clipping a particular section to enlarge a particular view or particular section of a block, you will be using another scale, right? You will be using another scale which basically is applied for that particular field or particular area, that you will be calling it as a local scale, right? The combination of global and local scale will get you a draft model or geometric data readily available, right? Next is your projections. Basically, while creating draft, you will be having two types of projection, sorry, three to be precise: isometric, orthographic, and perspective projection. Right? What do you mean by isometric is basically whenever in a coordinate system, right? All three coordinate systems are will be in the direction of 30 degrees, two planes, whereas other will be 90 with respect to each other, right? This 30-degree inclination will have or will add up a small scale factor, that is 0.7 or 0.6, right, to all the dimensions to get a reduced scale 3D model to generate your isometric projection of that particular model. Whereas for your orthographic, simple to your Cartesian system, right? Simple to your Cartesian system, that basically does is any view, any object that is placed under the first angle or third angle, or first quadrant or third quadrant, will give you separate types of projections, separate types of views, positioning. The same thing, what we can basically do is for orthographic, whenever a viewer sees and the rays of projectors are parallel to each other, and if an object is placed in the first quadrant, then you are calling it as first angle projection. If the same thing is placed on a third, it is a third angle projection. And the third one is your perspective projection. Perspective is from a corner or from one point of seeing how all the other elements are visible, right? Based on that, what you will be doing, you will be creating a view, right? And the last is nothing but your company. Under organization data, you are supposed to enter your company name or the name of your employer through which you will be working on. So all these data are related to your organization because it doesn't have to do anything with your geometry, right? It does have to do everything with your the company or the date of modifications or date of request, and what is the input data that you are giving to a company in order to better identification of your drawing or a part. Now coming to your technological data, what does it has? Basically, it has a geometry, right? Whatever the geometry 2D or 3D geometry that you are preferring to keep, that you will be having. It will be having a dimension, right? Defining a length of line to a particular degree. Let's say it's a 100 mm line. You are defining it, right? Next is your tolerances. What is the tolerance value? Is basically a small value, acceptable value, through which an object can, while manufacturing, can be deflected, right? Let's say for if it's 100 mm, you can go for 0.001 mm as an allowance to have it to maintain it correctly during assemblies. Whereas for surface finish, how well this 100 mm line is supposed to be surface finish? It is supposed to be smooth or rough or roughness at a particular degree, right? Or particular pattern, right? All these things are relevant to your technological data, which includes your final manufacturing. Next will be your material specifications or reference. What is the materials that you are requiring to in order to generate that part, right? Or basically a designer, what material did he consider while designing a part? For example, aluminium. A designer can use an aluminium part in order to identify or make his part out of aluminium. While manufacturing, the designer is supposed to give an input to use a particular type of aluminium in order to achieve the desired properties or desired values that he has designed it for, right? Next is your manufacturing procedures. What are the manufacturing processes that are required in order to clearly perform your product out, right? That you are doing. In what way is basically whenever, let's say for whatever example we are taking, a Coke can, right? According to the types of parts, let's take a car, which we have taken previous example. A car which has number of parts. Each parts will have its own manufacturing procedure to achieve a good quality finish as well as a good quality product out. Now, according to the procedures, your parts are assembled, parts, individual components are assembled. During that, what you will be taking care of are basically tolerances as well as dimensions, through which a manufacturing procedure is supposed to follow to get your parts out. These parts are assembled in a car maintaining the tolerances as well as your surface finish. Now, as soon as this part is all done, the last point, which is nothing but your inspection procedures. As we have discussed earlier during the design process, a car once out of your field, particularly a factory or a production plant, it is supposed to be inspected, right? It's supposed to be inspected to maintain its quality output, right? Inspection for defects, a test drive for faults, right? And look for colors, what we are sending out. All these are inspection processes. There are many more. These are few inspection processes on which it's supposed to happen, that you're looking after under technological data. Now, all this data, what we organize is basically organization as a technology order, can be clearly identified when you're considering a simple product of as an example. Now, what is a database? Is basically a collection of data which is shared throughout the process, right? Whenever is required, we are taking it up. Whenever we are modifying, we can modify, update it, refill it, or revisit it, everything. Now, what does it basically have? A database will have a data record. What do you mean by record? It's a fact or a myth, right? Fact or statement, let's say. Statement related to, in our case, it's a model, right? For example, we are taking a cube, right? A cube is value which has all sides as equal. We are considering it as for 10 mm, right? This 10 mm model, we are considering a cube of 10 mm is a statement or fact that can't be taken out because it's a true value, right? Other thing, let's say for a pyramid, the side of a pyramid or the slant height of a pyramid, all the things are few variations that can happen. Next is your data file. What does a data file consider? For example, in our geometry case, this 10 mm. A data file will have your complete folder, particularly a file, which consists of all your record, fields, and models. A simple folder, right, which holds your record as well as field as well as model data, everything together. Now coming to field, let's say under data field, for example, same example, 10 mm cube, what we have considered earlier, what will be in a dimension data of cube, which is equal to small blank, right? Now this blank is basically your field. What kind of field? Is basically dimensional field, right? Dimensional field, that in which a dimensional data is supposed to be shown. In our case, this instead of x's, what we'll be having? We'll be having 10, particularly mm, if it's maintaining global unit values, right? Next, data model is nothing but what kind of relationship we are maintaining with respect to all the file, right? A small relationship, because relationship between two separate data sets will give you a better approach to identify as well as get your access data more easier. So during this, what we'll see is, we will see the different data models that are available and we'll be using. The more common database models are basically your hierarchical model, network model, as well as your relational model. First, we'll look after your hierarchical model. During hierarchical model, what happens is a complete assembly file, in our case, a car, will be having number of parts, what is the description of each parts, what are the drawing numbers as well as remarks. This particularly is for complete assembly of a car, final product. Now this final product can be further divided into number of sub-assemblies which each have their individual part numbers, description, drawing numbers as well as remark. Right? Now each sub-assembly, similar to your previous assembly files, will be having individual components which have all the same. Right? The data shows a dependency values. For example, we will take an example for example, not the car. We will take another example for which a small protocol. We will take an organization, let's say, Institute of Aeronautical. Who reports to whom? A simple hierarchical model, right? Let's say a class. Out of a class, we are representing the whole class with the CR. What we usually do, basically, the CR reports to class in charge. The class in charges report to HOD, and HOD reports to principal. Right? It's a hierarchical model, a hierarchical protocol that usually educational institute will follow. Other example is basically if you're going for any software or any other company productions, small laborer will report to its manager, not manager directly. He will be reporting to, let's say, for any construction work, foreman to whom? Basically shop floor in charge. Shop floor in charge to your supervisor to manager to general manager or production manager if you're going for production side, or sometimes the same manager can also be called as production manager. Next, production manager to your general manager to CEO or managing director. Right? It's a small hierarchical model in company that most of the users follow. Let's say you're creating a part out of it, a small casting part that you're doing. Foreman, what he basically does is he machines or he prepares your part. Then he is supposed to be reported back to your shop floor in charge to your supervisor to production manager to general manager, then CEO. The foreman, in most of the cases, can't directly report your findings or report your issue directly to CEO, apart from some cases. Now, whenever the CEO wants company to perform at some particular speed or particular data out or particular production rate out, he will convey his message. To your CEO, general manager. General manager in turn conveys the same for production for supervisor to shop floor to foreman, so that then he will be able to perform at the rate that is decided by your CEO. Now in this, there are no dependencies. There are dependencies from one element to other, as well as there will be sub branches accordingly. Let's say, for example, one shop floor in charge. If you're having a shop floor of 50 foremen, right? These 50 foremen will be controlled by one shop floor in charge. A single shop floor will be again multiple shop floors will be controlled by supervisor in the same case. Now, coming to your next is basically your network model. What happens during network model? There will be a small connectivity while creating some part. For example, let's say I'm a customer, I'm ordering a part. right? I want a part. So for that, as a company, what it does basically, I will give a manufacturer a purchase order PO, right? I want, let's say, purchase order means it basically says I am conveying my message to you in a written form manner, such a way that I want this particular component of your company to be with us at whatever rate that we decide, right? According to that, what happens? Purchase parts are done. Or else, another example for us is better. If we are taking, let's say, for company gets an order, consumer order, right? According to the company, they require some parts which are not available to us. In order to acquire the parts, they will give some ancillary units to get the parts out. Now, whatever the information that are given through parts is basically your purchase order, right? We want this many parts to us in order to fulfill our own customer order, right? Now, these parts, whatever we are taking, are made accordingly to the customer order, right? According to the customer order, in which, as the customer order is getting generated, you are generating separate gateways. One is for invoices, other is for payments, right? Depending on the terms that the manufacturer as well as the consumer speaks or agrees to the terms, the invoices are generated either on the time of payment or after the payment, or same thing, the payments before or after. Now, in this case, sometimes whenever the under invoice a payment has been made, right, at the time under payments tab, it will be reflected. For example, another example is just basic Flipkart. What happens under Flipkart? I or you as a customer, you will be putting an order to it, right? Order of your phone, let's say a new phone. What happens during this is, as Flipkart as a mediator will process the order as well as payment as well as invoice. It will look after. So the Flipkart will give a purchase order to a company, right, to acquire that product out, acquire that product in. Now, as it gets, according to the consumer order, according to the order, it will generate two ways. First is a payment gateway, other is your invoice. In other terms, you are calling it as bill, right? As soon as you are making your payment, it gets reflected in your invoice one way, or that is your prepaid deliveries. Another way, you'll be getting a bill that you will be sending, against which you will be paying, that you are showing, right? These are few network models that are applicable for every element that you can. What happens in this basically, these two separate elements are interconnected, right? Two elements such as your order invoice, customer receipts as well as invoice paid in this case are interrelated. If, as with respect to your customer order, if I made a payment which is my prepaid, it gets updated to my invoice. That is one way. Or else, if an invoice is generated for a COD type of delivery, what happens? I will pay against the invoice during my delivery. The same payment will get accumulated against my customer order number, right? Now, what will be the data associated with all these elements that we have discussed is a simple part. In our case, it's a mobile of a manufacturer, and a purchase order from your Flipkart Whatever the examples we are taking, the same thing. The customer order is also from Flipkart, but from consumer side. This is with respect to him. Next, what does the customer order include? What is the order number? What are the customer address? What are the delivery dates? Everything related to your orders. Next, whatever with respect to payments, what is the payment date? What is the amount? What is the transaction numbers? Everything. What is the bank through which it has happened? All the details that will be enclosed within the payment tab. Next is your invoice. What is the invoice number, date, amount? What is the bill? How it has been played? How it has been dispatched? Everything data will be embedded into your network model. And last is your relational model. Relational model, for better explanation, let me just draw a cube. Right? Let me just write a cube. Simple. How many vertices we are having is basically 8 vertices and 12 faces. Sorry, 6 faces. 6 faces. 8 versus 6 faces. Now in this, all the 4 sides, all the 2 faces of the cube. Now in this, whenever a solid body of a cube has been considered, what happens is, it will be a complete solid body of A, B, C, D, 4, 3, 2, 1. That is a complete solid body. That is in this. What are the faces? Right? In your cube, what are the faces? Are basically A, B, C, D is a one of your faces. Next, A, B, 2, 1, B, C, 3, 2, and 1, right? B, C, 3, 2. This is this face. Next, this face done. A, B, C, D is done. A, D, 4, 1. Next, D, C, 3, 4. Right? These are few examples. It continues till how many? All the 6 faces are here. Right? Now, in order to make this face out, whatever the space we have taken, A, B, C, D, what are your vertices or what are your edges that are necessary? From A to B is 1. Next, B to C is second. Next, C to D is a third. Next, A to, sorry, it will be D to A. Right? These are your edges or lines that are needed in order to develop complete plane, which is your surface. Now during this, what are the vertices? For A, it will be a coordinate related to x, y, and z in a 3D space, similar to B, similar to C, similar to D. Right? Now in this, we can see from solid body a few faces, particularly if you are taking an example for a cube, a solid body has 6 faces. Each 6 faces will be having total how many edges? 12 edges. Right? These 12 edges will be having individually 12 different vertices that will be available for us. Right? Now, what? In order to make this out, in order to make an edge of A to B, 2 separate coordinate data for A, B. In order to make a BC, 2 separate coordinate data for B and C. Right? These relationships, right, dependencies from one to other on how well they are being made can be seen. It is very similar to your hierarchical model, but most of your geometrical models will use one which defines a less or which takes the less amount of energy or less amount of storage, as well as defines the database relations effectively. Right? Similar to what we have discussed, we will see. A solid has an edge. An edge will consist of a surface if you're considering for all the closed loop, right? If you're considering vertex, is nothing but a corner, right? All these things we will be having in terms of having a data out. On the same part, a product will be having multiple assemblies. Assemblies will be having number of parts, which also called as sub-assemblies, then assemblies. Then each single part is a solid body. Each solid body has its own faces, edges as well as vertices. Now these are dependent on each other. Particularly why I am saying dependent is based on the vertices you will be creating edges. Based on your edges you will be creating faces. Right? Based on your faces you will be creating a complete solid body. Right? Now all these first three, which is product, assembly as a single part, are in conjunction with your dimensions of particular body. Whereas for attributes, accordingly to a single part as an assembly, these are getting attributed. Right? Now this will be your data that you are supposed to have under while creating geometric model. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.